Welcome to our webinar today, Real-Time Log Analytics using Amazon Kinesis and Amazon Elasticsearch service. Our presenter today is Ray Zhu. Ray is a Senior Product Manager with AWS. And today with us, we also have a couple of moderators standing by as mentioned. So please make sure to engage with us and answer or ask any questions you may have so we can answer them throughout the presentation. Welcome, Ray. The floor is now yours.
Thank you, Quentin, and good afternoon, everyone. Thanks for joining today's webinar. The topic for today is real-time log analytics using Amazon Kinesis and Amazon Elasticsearch service. And the whole webinar will last for about 40 to 45 minutes, and at the end, we'll save some time for Q&A. And the focus for this webinar will be on the Kinesis part for real-time ingestion, because this is still a relatively new concept that many of our customers are not familiar with. So for today's session, we will first give you guys a brief overview of Amazon Kinesis and also Amazon's Elasticsearch service. Then we'll walk you through the entire process of setting up a real-time log analytics pipeline, including the ingestion piece and the analysis piece. So I believe all of you guys will get a deck after the presentation so that you can actually also use the deck as a step-by-step guideline as a lab course. So I highly encourage you guys to, after this session, go through the step-by-step guidelines yourself so that you'll get a real sense of how easy it is to set up a real-time streaming pipeline to analyze your log data. So Amazon Kinesis is AWS streaming data service. It makes it easy to collect, process, and analyze real-time streaming data so that you can get timely insights and react quickly to new information. There are three sub-services, or you can call that three different capabilities under the Amazon Kinesis service group. The first is the foundational service called Kinesis Streams. It stores data as a continuous replayable stream so that it powers your own custom applications. You can use different framework or technology of your choice to process the data in real time from a Kinesis stream, such as a KCL, a Kinesis Client Library application. You can use Spark Streaming, you can use a Lambda function, or you can use Kinesis Analytics. Then the second service called Kinesis Firehose. It's an abstraction layer on top of Kinesis Stream. It automatically loads your streaming data in near real time into different analytical and data storage destinations, including S3, Redshift, and Elasticsearch service, which is exactly for the topic today. Then the third service called Kinesis Analytics. It allows you to using standard SQL language to run query and analysis against the data stream directly. So you'd be able to use the SQL skill, which most of the customers already have today, to run a real-time analysis against the real-time data stream so that you can get your analysis results, gain insights against your data much sooner without learning any new technical skills or language. And again, for today's focus, we're going to be discuss Kinesis Firehose and use the streaming service Firehose to load data into Elasticsearch for analysis. So why should you use Firehose? First, it's easy to use. You'll see that during the later half of the presentation. It's just a matter of clicks on the Firehose console. Then you'd be able to set up a streaming data pipeline to load data continuously into your destinations. It is integrated with AWS Data Store, so you do not need to write the integration or write an application to move your streaming data into these data stores. It offers a serverless data transformation feature through an integration with AWS Lambda, so that as you transition your data from the data source to destination via Firehose, we will be able to transform, filter, and clean the data on the fly. It offers near real-time capability with a latency of minutes or seconds, depending on your buffering configurations, so that you'd be able to gain insights into your data much sooner than before. It's completely serverless. You do not manage any infrastructure or servers, and it doesn't require you to have any ongoing administration. At the same time, It charges for a gigabyte of data that you flow through the service. And it's truly pay as you go. You do not reserve any resource, and you pay zero if no data is going through the service. Amazon Elasticsearch service. It's a cost-effective managed service that makes it easy to deploy, manage, and scale open source Elasticsearch for log analytics, for text search, and more. It is Amazon managed version of the Elasticsearch cluster. It includes two different components today, the core search engine piece, Elasticsearch, and also the visualization piece, Kibana. And for those of you who are familiar with Elasticsearch, an often stack people use is called ELK, which stands for Elasticsearch, Logstash, and Kibana. Then the question might come up, where's the Logstash piece here? Well, the answer is Kinesis Firehose. Kinesis Firehose is a scalable serverless data ingestion solution with transformation capability on the fly to ingest data into Elasticsearch. So in this setting, you'll use Kinesis Firehose, Elasticsearch, and Kibana. Again, Elasticsearch service, it's easy to use. It just takes a couple of seconds to spin up a cluster from the Elasticsearch console. It uses open source framework so that it works with all the plugins the community has built around the Elasticsearch open source framework. It's secure, highly available, and again, tightly integrated with other AWS services such as IAM role for security control, CloudWatch for monitoring, and also Kinesis Firehose for data ingestion. It is easily scalable. You just add more nodes to your cluster when you need to scale up and reduce the number of nodes of your cluster when you need to scale down. There's an Elastic Load Balancer sitting in front that we manage that for you. All right, so we discussed about Kinesis Firehose, a real-time streaming data service with Elasticsearch service, which mostly customers use a service for real-time operational monitoring and alerting. So why does that matter, and why do these two services work so well together? It matters because there's time value of data, as shown on this graph. As time goes on, the value of the data diminishes dramatically. So if you're able to analyze and gain insight to your data sooner and take action sooner, it'll be more valuable and open up new use cases, which is why we're discussing this topic here today for real-time data analysis using these two AWS services. So before I go through the step-by-step introduction and walkthrough of how to set everything up, here is a high-level overview of the entire data pipeline. So it's fairly simple. It doesn't have a lot of complicated components, but it is super powerful with real-time ingestion and transformation and search and analysis. On the very left-hand side of this graph, you have data sources generating these data, log events in real time, and you push that into the Firehose service. The data source could be servers, could be mobile devices, could be IoT devices. Firehose is designed to be highly scalable, so you can actually push data from hundreds of thousands of devices concurrently into a single Firehose delivery stream. Then in the middle of the picture is the Firehose delivery stream. It has a serverless transformation capability that you can clean up and transform, properly format your data before you send the data into the final destination, Elasticsearch in this case. Firehose also offers a data backup feature. So in any case where your Elasticsearch cluster is not available, for example, when you are modifying your index, when you are maintaining your cluster or resizing your cluster, Firehose can back up these data into an S3 bucket so that you never lose any critical data, and you can always refill the data from S3 later on when your Elasticsearch cluster becomes available. At the same time, Firehose can also offer an option for you to back up all the data concurrently to S3 as all the data is flowing into Elasticsearch cluster. So for some of the customers, they use Elasticsearch as a real-time search monitoring store and technology. And at the same time, they want to back up all the data into S3 so that later on they can use tools like Hadoop for more complex batch-oriented processing and long-term analysis. All right, now let's dive into the step-by-step process of setting up the entire data pipeline so that you can get a sense of how easy it is to get started with these two services. So step number one, I need to create an Amazon Elasticsearch cluster where all my log data will flow into for me to run search, analysis, dashboard, and alarm or alert. So I go to Elasticsearch console. I will first define a domain name for my cluster. Here I'm naming it Ray Webinar. Then I'll pick a latest Elasticsearch version that is supported by an Amazon Elasticsearch service. In the cluster configuration, you can choose what instance type you want to use for your cluster, how many nodes you want for your cluster. So here I'm just using one node, using the M4 large for this demonstration purpose. You can also attach an EBS volume to your cluster for storing your data records. Here I'm attaching an SSD with 10 gigabytes of volume to my cluster. Then you can also have access control policy through a couple of different mechanisms. You can either use AWS IAM role, IAM user to control access to your cluster. You can also restrict by IP address. And you can also deny access from everywhere or allow access from everywhere, which we do not recommend for security reasons. So once you set up security access policy, you're all set. Click on create a cluster, then minutes later, you will have an Elasticsearch cluster up and running and properly configured. Now step two, set up the Firehose delivery stream. If you recall, this will be your real-time ingestion pipeline that continuously ingests, transforms, and then load the data into the Elasticsearch cluster. You go to Firehose console. Step one, you will configure destination information. In this case, I will choose Amazon Elasticsearch service as my destination, and then name it Ray Webinar as my delivery stream name. Then I'll put in the domain name that I just created from the Elasticsearch cluster and also specify index and type, which will logically organize the data I'm going to ingest into the cluster. Now, Firehose also has an index rotation feature. So as you might know, Elasticsearch doesn't serve as a long-term storage. Customers rotate the data in Elasticsearch over time so that you retire the old data and always keep the most refreshed data on the hard disk. Firehose is able to rotate the index by hourly, daily, weekly, or monthly interval. There's also a retry duration configuration. So in circumstances when Firehose is not able to deliver the data into your Elasticsearch cluster, it determines how long Firehose should retry until it gives up on that batch of data and then move on to the next. And for all the skipped data, it'll be securely backed up into your S3 bucket. So this retry duration configuration is a trade-off between do you care about data freshness or data completeness? You can configure this option for somewhere between 0 seconds, which is no retry, and up to 2 hours. So for example, for use cases where it's absolutely critical to get the most fresh data and all the old data will no longer be valuable for the use case, you might want to set a short retry duration. So in that way, you always make sure Firehose deliver the most fresh data into your Elasticsearch cluster. And for different set of use case where you do have some tolerance on latency, but you want to make sure all the data gets into Elasticsearch, then you can set a long window. For example, if you set it into 2 hours, it's long enough to cover most of the maintenance or resizing or index modification on your Elasticsearch cluster. So Firehose will keep retrying until it succeeds in these kind of scenarios. Then there's this backup option where you can configure, to back up failed documents only into an S3 bucket, or concurrently as data flowing through Elasticsearch, just back up everything into S3 bucket for a different batch flow. You can also specify an S3 prefix, so in case you use that bucket for different purposes, you have a prefix to identify the type of data under that particular prefix. Then step number 2, going through configurations. As I mentioned, Firehose is tightly integrated with AWS Lambda for data transformation as data is transitioning through Firehose into your destination. When we enable data transformation, you can choose an existing Lambda function you already have, or you can create a function from the Firehose console. For common data transformation logic, we offer Lambda blueprints so that you can use that out of the box or modify that accordingly. For example, converting Apache log or syslog into JSON or CSV. In this case, I'm working with Apache log for this demonstration. So I'm just going to use Apache log to JSON. It's an out-of-box Lambda blueprints. I'll just set up function through that blueprints, and I do not need to write a single line of code. And as you know, I'll convert Apache log to JSON because Elasticsearch takes JSON data for schematizing and for search query. Then we also have buffering options. So Firehose, as it takes streaming data from your data producers, it buffers the data before it sends the data to Elasticsearch. So that way, data can be efficiently indexed into your Elasticsearch cluster without using too much resource, so that the resource on the cluster can be preserved for search and query. You can configure Firehose buffering around 2 different dimensions. You can configure by size, somewhere between 1 megabyte and 100 megabytes, or you can configure buffering interval. You can configure somewhere between 60 seconds all the way up to 15 minutes. Whichever condition gets satisfied first will trigger the data delivery into your Elasticsearch cluster. And for the backup path into S3, you can also configure Firehose to compress the data before delivering to S3. We support common compression formats such as zip, gzip, and snappy. Firehose can also use one of your KMS keys to trigger S3's server-side encryption while it's sending data into your S3 bucket. Next is the error logging feature. So Firehose is a fully managed service. It handles all the data delivery and failover and retry behind the scene for you so that you do not need to worry about it. But in cases when data delivery or data transformation fails, Firehose offers the capability to log that error message back to CloudWatch log so that you can clearly see what has gone wrong for troubleshooting purpose. It's extremely handy when you initially set up the Firehose delivery stream and the pipeline so that you know if there's any misconfiguration. For example, you've put in the wrong index name. You will see the error message so that you can fix accordingly. Lastly, on the configuration page is the IAM role. So based on the resource you configure within Firehose, for example, your Elasticsearch cluster, S3 bucket, and CloudWatch log group, Firehose will need to gain access to this resource so that it can deliver these data on your behalf. This role is to make sure only Firehose service has access and has access to only these resources you configured in this delivery stream for security control. All right, that's step 2. So it's really 3 configuration pages on the Firehose console. As you click through make all the configuration, now you've had a real-time ETL streaming data pipeline set up that will constantly transfer data from your data producer into your Elasticsearch cluster and transform the data from Apache log into a JSON object on the fly. Step number 3, send data to the Firehose delivery stream. Firehose offers a couple of different ways for you to send data into the service. We offer 2 different REST APIs. The first one called put record, where you have a single record, a single Elasticsearch document through the API to get the data into Firehose. The second REST API is called per record batch. So as the name indicates, that allows you to put multiple data records into a single API call. So that way you can achieve high efficiency and high throughput on your data producers. We also offer a Kinesis agent, which is a Java application that you can install on your Linux or Unix-based servers. What it does is it'll continuously monitoring the local log files. And as new data gets written into the file, the agent will pick up that new record and forward that into the Firehose service. Now, in this webinar, this is a sample log data. As you can see, it's a common Apache log. It's unstructured. You see IP address, timestamp, requests, size of the requests, but you don't see any schema here. This will be how the data will look like after data transformation using Firehose data transformation feature. Use the Lambda blueprints I just mentioned to convert Apache log into JSON. Now you can clearly see you got a host, which is an IP address of the host. You have request, you have bytes, which is the size of the request. So that with this properly formatted record, Elasticsearch is able to take the data and run proper search. Now, as I mentioned, there are different ways for you to send data into Firehose service in production environment. In this case, for demonstration and testing purpose, we have an open source tool called Amazon Kinesis Data Generator. It allows you to generate dummy data record and send it into Kinesis Streams or Kinesis Firehose. I've put the URL here so that when you try this walkthrough out yourself, you can use this URL to launch the Kinesis Data Generator, and you can specify different kind of data patterns for the tool to generate data and send it into Firehose service. So it's really handy for the initial testing purpose before you set up your true production data producer to push data into the Kinesis services. So I'm using this tool to send raw Apache log data into the Kinesis Firehose service. If you recall, I've specified a Lambda function to convert Apache log into JSON object in my Firehose delivery stream. So as this raw log data gets continuously sent into the Firehose delivery stream, the Firehose service will use that Lambda function to transform that raw Apache log line into a JSON object, then continuously ship the data into your Elasticsearch cluster. And if any failure happens during delivery or transformation, Firehose will retry throughout the period of time that we specify in the Firehose delivery stream. And for any failure afterwards, it'll securely back up the data into your S3 bucket. You can also use Firehose to compress the data before it sends the data to S3, and then trigger S3's server-side encryption. So now, as data keeps getting pushed through the Firehose service, it'll land in my Elasticsearch cluster. So here I'm using Kibana, run a simple query, just get everything out of the domain and index I just configured in my Firehose delivery stream. So as you can see, from raw Apache log from the data generator, right now in my Elasticsearch index, I see these data has been structured with field and data gets pushed through. As I keep refreshing this search result, you'll see new records gets populated continuously. I'm also creating a very simple pie graph to visualize my data. Here I'm just trying to do a count of the requests based on the response code. So as you can see, majority of the requests generated from the data generator has 200 response code, which means they succeeded. We also have a handful of responses with 300, 400, and 500 code. Of course, with Kibana, you can create much more complex and much more nicer graphs and dashboards. But here I'm just using a simple example to illustrate what you can do with the search engine and the visualization tool, Kibana. Now, as you recall, we just gone through the process to set up a real-time ingestion pipeline from Firehose to your Elasticsearch cluster, then using Kibana to search the records or visualize the record through a graph. So the Firehose ingestion pipeline is entirely managed service and it's serverless. So as I mentioned, it abstracts away a lot of the maintenance work and the complexity out of the picture for you so that you can focus on how to leverage the data, use the data, analyze the data, and then take actions. On the other side, we also want to make sure as you take advantage of a managed service, you also have visibility and insights into what's going on in the pipeline. So first, Firehose offer a lot of CloudWatch metrics so that you can clearly see things like how much data has been putting into the Firehose delivery stream, how much data has been sent into S3 bucket for backup purpose, and how much of my data has been sent into Elasticsearch cluster. Am I falling behind? Am I getting fresh data in my Elasticsearch cluster? Or are there any failures when Firehose tries to do data transformation or send data into my Elasticsearch cluster? So you can see all these metrics. So as you take advantage of a managed service, you also have insights into what's going on so that you can constantly monitor this ingestion pipeline. As I mentioned earlier, other than metrics, which tells you if anything has gone wrong or if anything has been working fine, but if anything has gone wrong, you need a bit more information to tell what has gone wrong and how should I fix it. So Firehose integrates with CloudWatch logs. So anytime when there's delivery or transformation failure, Firehose will log the error message into your CloudWatch log group. And you can also see this error message from the Firehose console. So in this case, I'm setting too short of Lambda function timeout setting. I'm using 1 second here just for the purpose of this, for the purpose of this demonstration. But the data transformation in Lambda takes a bit longer than 1 second. So the function times out before Firehose is able to take the transformed data back from Lambda. So here I can clearly see the message tells me the invocation of the Lambda function has timed out. I should go increase the timeout setting on the Lambda function, then it'll be able to transform the data and return it back to Firehose service for the final delivery into the Elasticsearch cluster. So these are relatively short step-by-step walkthrough, among 30 minutes. So hopefully this gives you guys an overview of the step-by-step and how easy it is to set up a real-time streaming pipeline to transform and ingest data into your Elasticsearch cluster. So again, I highly encourage all of you guys, when you receive the deck, use the step-by-step guideline, try to go through the process yourself and get a feeling of how easy it is to set up this pipeline. So as you go back and figure out any real-time analysis or log ingestion requirements within your organization, you can use Firehose and Amazon Elasticsearch service to set up this pipeline for your organization.